Hello friends, in this session we will talk about carbohydrates, which consists of the Barfoed test and the Osazone test. Keep on watching guys! Let me introduce our group members. First is Galuh Cantya Kusumawicitra, the second is Hafid Ainun Fajri, and the last is Imtihani Afiyah Najiyah. Barfoed test. The aim is to distinguish carbohydrates from disaccharides and monosaccharides, and the basic principles is based on the reaction of a carbohydrate with a Barfoed solution in an acidic atmosphere. It is reduced to Cu2O and will form a brick red precipitate. Monosaccharides will reduce faster than disaccharides. The Barfoed test equipment. First is test tubes, the second is bottle bath, and the last is drop pipette. The test material of sample of Barfoed test. The first is sucrose solution, second lactose solution, third fructose solution, fourth maltose solution, and the last is galactose solution. Barfoed reagent. Dissolve 48 grams of Cu acetate in 900 ml of boiling water. Immediately add 50 ml of 8.5% lactic acid to the hot solution. Shake until all the sediment dissolve. Dilute with aqueous to 1000 ml. Copper acetate and acetic acid. How the Barfoed test works. First, prepare 5 test tubes. Next, enter into the test tube 2 ml of Barfoed solution each. Next, at each 0.5 ml of sample or 10 drops, mix until homogeneous. Next, heat in boiling water bath for 5 minutes. And the last is observe the occurrence of brick red deposits in each test tube. Barfoed test result. The first sample is glucose. The result is positive and the color is blue solution with brick red precipitate. The second is fructose. The result is positive and the color is blue solution with brick red precipitate. The third is sucrose. The result is negative and the color is greenish blue. The fourth is lactose. The result is negative and the color is greenish blue. And the last is galactose. The result is positive and the color is blue solution with brick red precipitate. If the result is positive, it means the sample contains monosaccharide, and if the result is negative, it means the sample does not contain monosaccharides. This is the figure of Barfoed test result, are negative in left and positive in right.
Discussions. In accordance with what is stated in the practical model, it says positive if the solution is deposited after heating, while the sign negative is given if there is no precipitate in the solutions. When the solution heated in a water bath, a color change occurs. The sequence of colors that occurs start with the formation of colors, from blue to green, then yellow, then red, so yellow the formations. Finally, a brick red deposit is before the depositions. Bubbles appear, which then produce sediment. Discussions. According to the results of research including monosaccharide carbohydrates, the bottom edge of the solution will change color to brick red. This is due to the fact that there are more ketone aldehyde groups. The sample test, namely fructose, maltose, and galactose, show positive results which indicate that the sample contains reducing sugars. However, the results for lactose and sucrose are negative. In this experiment, that was obtained that a monosaccharide can be distinguished from a disaccharide, which can be observed from the formation of brick red deposits in glucose, fructose, and galactose compounds, while lactose and sucrose do not form brick red deposits, so they are considered disaccharides. Similar to Benedict reagent, this Barfoed reagent also reduces Cu 2 positive ions to Cu positive ions. Basically, monosaccharide can reduce faster than disaccharide. Disaccharide with low concentrations did not give a positive result. Therefore, the disaccharide test solution did not form a red-orange color in this experiment. Conclusion: the Barfoed test is performed to determine the presence or absence of monosaccharide in the solutions. Monosaccharide and disaccharide can be distinguished by the formation of bright deposit in monosaccharide, whereas disaccharide do not form bright deposit. Osazone test. Aim: prove that carbohydrates can form Osazone crystals and can be used for identification based on their crystal shape. Basic principles: an aldose or ketose will react with phenylhydrazine to form phenylhydrazone. That result of phenylhydrazone oxidation will react with excess phenylhydrazine to form Osazone. It can be seen from the crystal form. Osazone test equipment: first, test tube; second, water bath; third, microscope; fourth, object glass; fifth, drop pipette. The test material sample of Osazone test: first, maltose solutions; second, galactose solutions; third, lactose solutions; fourth, glucose solutions; fifth, arabinose solution. Reagents: Osazone reagents. The reagents used in the Osazone test is a phenylhydrazine solution made of 6 gram phenylhydrazine plus 9 gram natrium acetate plus 90 ml water. Mix and stir until dissolved.
How the Osazone test works: first, enter into a test tube with 100 mg of Osazone reagent. Second, add 1 ml of each sample. Mix until homogeneous. Third, cover the test tube with a cotton ball. Heat it in a water bath until crystals form. Fourth, the way to check this is by looking at the crystal under a microscope at magnification of 100 and 400 times. The next slide is about Osazone test result. The sample is lactose, glucose, maltose, galactose, and arabinose. And the result of all tests is yellow precipitate. The explanation is the lactose forms crystals like a power puff. Number 2, maltose. The explanation is maltose forms petal-shaped crystals. Number 3, glucose. The explanation is glucose and from and broom or needle-shaped crystal. Number 4 is galactose. The explanation is galactose from crystal in the form of rock big plates. Number 5, arabinose. The explanation is from crystal. The deposits are dark brown or reddish brown. The next slide is difference between Osazone and hydrazone. Osazone is a complex substance resulting from the reaction of carbohydrate with phenylhydrazine, which is insoluble in water and is easy to isolate. While the hydrazone is a complex substance resulting from the reaction of carbohydrate with phenylhydrazine, which is soluble in water, soluble and difficult to isolate. Discussion 1. In the Osazone test, the underlying principle is heating carbohydrates that have an aldehyde or ketone group together with excessive phenylhydrazine to form hydrazone or Osazone. The Osazone has a crystal form and a unique melting point for each carbohydrate. From each Osazone crystal form, it can be used to identify carbohydrates and is one way to distinguish several monosaccharides. From example between glucose and galactose found in the urine of women who are breastfeeding. Next, Osazone disaccharide dissolves in boiling water and reforms when cooled. But sucrose does not form Osazone because the aldehyde and ketone groups attached to the monomers are not free. On the other hand, Osazone monosaccharides are insoluble in boiling water. Next, discussion 2. First, the process of forming Osazone crystals begins with sugar molecules that combine with phenylhydrazine, then heated to form the glucophenylhydrazone, which is water-soluble and difficult to isolate. These crystals are yellow in color. Second, with the continuous heating, the excess phenylhydrazine will reach further from the glucosazone in the form of orange or yellow crystal. Discussion 3. First, the experimental results showed that the 5 samples glucose, arabinose, maltose, lactose, and galactose were held that there is yellow sediment. This indicates that all samples have ketone or aldehyde groups which heated when with phenylhydrazine will form Osazone crystal reaction that occur. First, galactose and arabinose are aldoses because an aldehyde have the aldehyde group. Maltose and lactose are disaccharides classified as reducing sugar because they have a free aldehyde group or a free ketone group. Last, glucose is a monosaccharide which is classified as a reducing sugar because it has a free aldehyde group or a free ketone group. Next, discussion 4. First, the error factor that can occur with conducting an experiment can affect the reaction result, such as a yellow color change in the solution and the formation of Osazone. Next, the practitioner is not careful enough. The addition of too much or too little phenylhydrazine solution is not in accordance with the procedure. I think that the not in accordance with procedure can also be a factor for errors in carrying out this Osazone test. The conclusion of our analysis is the Osazone test is performed to determine the presence of aldose or ketose content. In this test, it is done by fractioning phenylhydrazine into solution. A positive fraction is characterized by the presence of a precipitated and produces a yellow solution after heating. A solution test showed positive result to that it can be concluded that the 5 solutions glucose, arabinose, maltose, lactose, and galactose have carbon or aldehyde groups which can form Osazone catalyst when heated.
This is the references that we use in this video. Thank you for watching, and if you any questions, please comment below. Bye bye!